Okay, I'm going to talk a little bit about entering your breeding bird, not your breeding bird survey, your point count with distance sampling data into Excel. The format is going to look a little bit different this week compared to other types of survey data, and we're going to use a format called a flat file. Sometimes when you're entering bird abundance numbers into a spreadsheet, you're able to use each column in your data set as an individual point count survey, and then each row, in your data set. So in this case, you might have plot A11 and then another plot and then another plot. And so each row in the data set is a point count survey. And then your columns are different birds that you observed, and you can enter the numbers. Or sometimes it's the opposite. You have your columns as your points and your rows are the species, and you can enter for each point the abundances of the species you observe. You can do that sometimes depending on your survey. If it's a relatively simple survey, you can use that approach. That format is called a matrix, in which you have similar types of data in your columns often that could actually be lumped into a single column called species. And so this is a flat file in which that is the case. And so what we have here is a lot of redundant data. So we have what I think to be always important information in the spreadsheet: where you're collecting your information, the site, your date, the time, and then the place where you did your point count. In this case, the identifier is a plot number, which is a letter and number code that gives you basically an X and Y indication of where that plot is. Here's your latitude, longitude, and then a broad categorization of the habitat type, whether it was primarily coniferous or hardwood forest. And I'm going to actually delete this row here because it shows up in another part of the data set. And then here's your survey of species. These are 4-letter codes for North American bird species, and each row in this data set is a species that was observed on a survey. And so that's why we have so many rows, and there's some redundancy, because we want to capture our observation. Every observation in the data set has a separate row to it. And so our samples, which are here, are our plots, and our observations are contained in each individual row, and our observations are our species. With each species in this survey, the observer noted whether it was detected orally or visually, how many were observed moving together. So sometimes you have flocks of birds moving together, and that's considered a single sample. For the purposes of a point count survey you can count each individual you see as a single cluster size of 1. But you have this numeric data now in the data set where you can tally up and get abundances. And then you have the measure of distance of the bird from the observer. And that is something that we want to be using to determine how we're detecting species on these surveys and detecting individual birds. And so we're going to do this by, the first thing we're going to do is generate a histogram of this data set. And I want to add that you'll have also habitat data that you collect on your survey that you're going to enter on another worksheet. And sometimes you have to spend some time modifying your data set to do your graphs, because depending on what you're trying to look at, you might need a summarized data for every plot, or you might need those individual observations. And the first thing that you may want to do is to generate a histogram that plots your detections, that looks at how many times you're detecting birds at these different distances. And so we're going to look at these individual detections here. And the first thing I want to do is I'm going to generate a histogram, but I want to get an idea of the range of distances that birds were being detected at on these surveys. This is an actual survey from 2008 of birds at these different plots in the campus forest. So these are all plots from the campus forest, and they're long-term monitoring plots with vegetation data regularly observed as well. So the first thing I want to do is just get this idea of what is the range of distances. And so I'm going to do a filter on this data set first. And I'm going to go into column distance, and I'm just going to scroll down and look, because what it's going to tell me here is it's going to show me that there were observations that were distance 0, 1, 2, 3, and this is all in meters, all the way up to 150 meters. And it looks like there might even be some data where there's blanks where distance wasn't estimated. So it looks like my maximum distance is 150 meters. My minimum distance was 0. And so that starts to give me an idea, okay, if I wanted to look at a histogram, how would I bend the data? Would I bend it into 10-meter increments or 20-meter increments? And I think probably 20-meter increments is the way I'm going to want to go for the first pass, and then maybe I'll alter it a little bit. So I'm going to click OK, and I'm actually going to remove that filter. Okay, I paused for just a second to double check to make sure I could do this in this version of Excel. And this is Excel 2016. So I'm going to go through generating this histogram using Excel 2016. I will also take you through a slightly more cumbersome way to generate a histogram in Excel, but it's still doable. But this is with Excel 2016. You can basically select your range of data, which is already selected here. And actually up in the, you can select insert. Let me make sure this is really truly selected here. Select this again. So I'm selecting the entire column with my distances. And I'm going to go to insert, and then there's this whole section on charts. And there should be a statistical chart option here. And it will look like this blue bar chart. And so if I select insert statistic chart, then the first thing that appears is a histogram. And you simply can select histogram, and it will automatically generate a histogram for you. It will assign bins based on the data. It probably just divides them up by the maximum, minimum, and some other functions. It uses some algorithm. But what we can see here, this is actually not a terribly bad histogram. It gives us some information here. So I'm going to drag it down so that we can see it a bit better, or expand it at least. And what we can see from this histogram is that we have this function that basically with low detections very close to the observer, and then increasing detections further away from the observer, and then falling number of detections past a certain distance. And this histogram that we're seeing here actually fits very well with what we expect to observe in a point count with distance sampling, in part because once we're sampling close to the observer, we're sampling a very small area. And so as you're measuring increasing distances away from the observer, you're actually increasing your sampling area. So up to some degree, you're going to see this increase in numbers of species. And then at some point, that distance is going to get so far away that it's influencing the observer's ability to detect. And that might differ on the different habitats. And so then you start to see this drop. And I would say right about here, which is, if I look at the distance on this, right about here, it looks to start to become quite flat. And so this is between 68.9 and 74.2 meters. And just visually looking, so I see this, I'm going to see if I can move this to move chart to a new sheet so that we can look at it together a little bit better. But what you're looking for is what we would call an elbow in the data set. And so, and that's with a histogram. Okay, here we go again. It's this flattening out of the tail. And to me, right about here is where it looks like it's going from a decline to a flattening. And it's somewhat subjective, but I'd say most people would probably say, oh, right about here, it's going from decline to being fairly flat. And this is a long tail of, okay, sometimes the observer was able to detect individuals, but not on many occasions were there many detections past, say, 74.2. So this is right where it starts to flatten. Some people might say, okay, I'm going to go out to 95.4. And actually, if you were to go out to 95.4, that's probably like 99% of the detections are out there. And at 74.2, you're probably looking at about 95% of the detections. You can actually generate some statistics if you know how to calculate a standard deviation. It's a very quick and easy step from the standard deviation to get a standard error. And 2 standard errors, roughly, is your 95% confidence interval. In fact, it's 1.96, I think, times the standard error is a 95% confidence interval. But we can also, this week, I'm just asking you to use this visual examination of a histogram to say, okay, here is the point at which most of my observations were being made, about 95%. So once you get this flattening. And so here, my detection radius, my effective detection radius, where I'm detecting most things in this survey, is probably around 75 meters. Past 75 meters, the detections were pretty low. And in fact, most of the detections were right around here. So my best detection was at about 37 meters away. So if I had set a fixed radius plot of 50 meters, that would have been reasonable, but I was still been missing some of a decent number of species. And so that's how you generate a histogram if you have Excel 2016. Some of you, I know that you can access Excel through your OneDrive, and what I don't know is how much of it, how its functionality is compared to this Excel. And so another way that you can generate a histogram using any version of Excel is to select your range of data, just like we did before. Okay, and you can click Insert, or actually you go to Data. You go to the Data tab, and you, on the far right, select Data Analysis. And in Data Analysis, you can find the option for histogram, and you click OK. And you put in your input range, which is your range of distances. In this case, it's cell H2 all the way down through cell H2019. And I'm not going to assign a bin range here. I'm going to let Excel do it by default because that's what the histogram option did just now. Oh, input range contains non-numeric data. Let's try this again. So let's go up here, and we're going to select our top number. Oh, it's because it's actually K that I'm trying to select. Okay, so here we go. We're running down here to the bottom here, all the way down to K 2019. So there's my range. I'm not going to select the bin range. And what the histogram option in this case does is it gives me this table and it assigns bins for me. And so what I can then do is I can then select these data. It says there's more that are 2. I'm just going to throw those 2 out for now. And those were probably observations detections that were way further away than 146.6 meters. So here is, I'm selecting this, and I'm going to insert. I'm going to the Insert tab, and let's pretend I don't have this statistic chart function. I'm going to select Insert a Basic Column Chart. And it looks like I have to do this, let's see here, or I could select this kind of chart. Let's do this chart. And so I'm going to select this bar chart, this type of bar chart, where it's automatically reading here that my bins, okay, are this first column, column A, are my bins, and column B are my frequencies. So I'm going to select OK. And I get this a little less pretty chart. But let's just kind of go and look at, make sure it's matching up. So 27, if I go down up to 27, yes, there's 109 observations. So I had 179 detections at 27 meters away. And so this is aligning pretty well with the histogram I have that was automatically generated with the chart. The difference is that these bars aren't touching, but you can still see the same pattern in the data, and the bins are slightly different. But if I look for an elbow again in the data set, so we have low numbers here, and as we move away in distance, we're sampling a larger area, and we get this increase in detections, and then it starts to drop again, and right where I see a leveling off is somewhere around a little more than 75 meters. So I'm saying slightly different things because of the slightly different bends in this histogram, but there's a lot of congruence here, in that right around between 75 and 80 meters away from the observer in this data set, the detections were almost nothing. They were pretty flat and low. Okay, and I would say that would be my cutoff for the radius. And if you wanted to be confident that you're getting everything that's there, you probably would select something even closer, like 27 meters. But generally, we would take the 95% of these detections were falling around something by 75 meters. Okay, so that's how you would generate those histograms. If I want to generate a histogram for two different habitat types to see if my detections were different, I would go through this process again and generate two histograms. So if I go back to my original data set here, sometimes with Zoom I have a hard time getting to it. Okay, here we go. I'm going to actually copy and paste this column called distance next to a broad habitat category. And so I have conifer or hardwood, and I'm just going to kind of scroll down, because what I want to do to make this easy is to sort. Yes, it's not sorted yet. I want to sort the entire data set so that all the conifer plots are together and all of the hardwood plots are together. And I can do that with a simple sort. I select the entire data set, and in the Home tab, I go to Sort and Filter, and I select Custom Sort. And this menu pops up, and I say I'm going to sort by Con HW. And then I select OK. And it's going to sort by alphabetically by whether it was identified as conifer, scrolling, or hardwood. Okay. And so I can now generate a histogram of just the conifer forest. And I'm going to do this using the easy method, but know that or the one-step method. Both methods are pretty easy, but the quicker method. So I'm going to generate a histogram for just conifers. I'm going to insert histogram. Okay, so this is the one for, whoa, don't do that. Here's the chart for, in fact, I'm going to say, call this conifer. Okay, and then I'm going to select, double check and make sure I'm selecting hardwoods here. Yep, so I'm going to select the range of data that aligns with hardwoods. It's in my detection distances in the hardwoods. Select it, go to Insert, make a histogram, and then I'm going to title this Hardwoods for now, okay? So I know which one is which, yes. And so I'm going to actually drag this chart up. You can see that the bin range is a bit different, and you can modify those things in a histogram if you want to. See if I can drag this up. Yes, okay. Can I do this? It's going to be kind of slow, so excuse me while we drag this chart up so that we can look at them side by side. In fact, I'm going to pause so that you're not having to watch me do this. Okay, so I actually moved these to a new worksheet so that you could look at them side by side with hardwoods and conifer. And so you can see the bin sizes are a bit different here because there were more observations in conifer forests, but I can still find what I would call an elbow, a flattening of the hardwood curve, which is around 77 meters away. And if I look at the conifer curve, I see a flattening around 83 meters away. So these detection distances are pretty similar in these two forest types in terms of where you're no longer really getting detections anymore. And so you might find that if you're surveying two different habitats, like a very open habitat or compared to a very closed habitat, you might have really different detection, what we call detection functions, so the shapes of the functions. In this case, if I were to assume some radius for my point, it would be pretty similar. If I looked at this, I'd say, oh, I would definitely not want to do a fixed radius of anything larger than 80 meters away. And actually, I'm saying like my maximum detections here at about 22 meters away in hardwood, and it looks like about 25 to 30 meters away in coniferous forests. That's where the sort of average numbers of detections are. And so they're slightly different, with detections being a bit higher further away in the coniferous forest from this data, and these look like pretty good data. So that's how you do your histograms. There's also the options of generating bar charts, and well, we're asking you to generate a bar chart comparing abundances of the birds in the two habitat types, and then comparing some environmental data. And I'll do that in another video.